How about that? So when we say a function is a linear function, let me give you multiple choice. So, which one of those is a linear function? Does anybody know? What in the world is a linear function? Yeah, it's B. And what we mean, linear function means x to the first power. Not x squared, not x in the denominator, not x in the power zone. Does that make sense? All those are no-nos. So we just mean just like regular x, not in somewhere weird like the power zone or the denominator or anything like that. Just regular x. And not x squared, not x cubed, not higher powers. Just regular x. So y equals 4x minus 7 would be an example of a linear function. Now, why do we call it linear? Why do we use that word, do you think? Linear. Yeah, the graph, guess what the picture looks like when we graph it? It's a straight line. Notice it doesn't have curvature to it. It doesn't bend in any way or make a V or any of those other ones we've looked at before. It just is a straight line. The graph is just a straight line. So they're really the most simple kind of functions. They're just straight line graphs. And they're just regular x to the first power. They might have a number in front like the 4 and a number added or subtracted at the back like the minus 7. But that's all it's to them. Linear functions. They have now the number in the very front. What's that number called? The m, yeah. Remember, it's y equals mx. I should probably go back here where we have a little room to write. Kind of scribbling everywhere. Yeah, so a linear function is something like y equals mx plus b, like y equals 4x minus 7. Yeah, the 7 is the slope, the m. That's right. And anybody remember what the minus 7 is? I'd be impressed if you did. It's the Y-Intercept. And we'll get to that today as we're looking through these. So that's the basic, that's what both these sections, that's what all chapter, we're going to do all of chapter 4 right now, 4.1 and 4.2. There's just two tiny sections. Well, they're not tiny, but two sections is all there is to chapter 4, 4.1 and 4.2. It's all about linear functions, which have a slope and a Y-intercept. Have a number next to x and another number added or subtracted at the back. The first number is multiplied by x, right? And the second number is added or subtracted in the back of the x. That's a linear function. All right. Back to the questions. So here we go with question number 1. And there's going to be a lot of word problems on these. They want us to really understand, which is good. I know word problems can be hard, but it's nice to make it real. So here we go. A town's population has been growing linearly. See that key word there? That means if you graphed if you did a graph of their population over time, it would be some kind of straight line. It wouldn't be a curve. It wouldn't curve up or curve down. It'd be a straight line growth, linear growth. In 2003, the population was 58,000. The population has been growing by 700 people each year. So every year, 700 more people in the town. It's kind of like Fresno. I think that's about what Fresno's doing, isn't it? Mm-hmm. More houses going in. We're going by. And traffic's getting a little tighter, isn't it? Yeah. Anyway, so all right. So let's see if we can answer their real life questions here. So write an equation for the population P X years after 2003. Okay, so they want some kind of population. Now, we know it's linear, which means what? It's like mx plus b, because it's linear. We know it's not x squared. It's got, nothing fancy. It's just mx plus b, just x to the first power, like that. So really, we just have to find the m, and we have to find the b. So what do you think? The population was 58,000. That's going to be the number that goes back here. Because that's the starting amount. The 58,000 is what the population started out to be. And where's the 700 going to go? They gave us two numbers, right? Yeah, that's in front of the X. And there we go. That's all we got to do. There's the formula. 700X plus 58,000. And then they do a follow-up question. They say, now that you've got that formula, so that's, here, let me put it over here. This is 700X plus 58,000. I'll move it over there. And now their follow-up question is, use the formula to find the population in 2009. So how can I use that formula to find out what the population will be, or was, I guess was, past tense, 2009?
You plug in the amount of years between 2009 and 2009 to...
Good eye. Yeah, exactly. Did you notice it started 2003, huh? And so 2003. 2009 is 6 years later, isn't it? Good job. They're going to do this on lots of these problems. They're always going to have like a starting year. So that's exactly right. You want to see where they start and then just say, well, how far since then? So this is 6 years later. So what do you think I'm going to do with that 6? X, huh? That's what we plug in. That's X. Yeah, and you can tell right there, because see what this sentence says right here? X is what? X is years after 2003. So yeah, so X is 6. So we just plug in X equals 6 to that formula. So let's do it. The population then will be 700 times 6 plus 58,000. So use your calculator. 42, is it 62,200? There we go. That would be the population 6 years later. It's going up by 700 a year. Just plug in. And that makes sense, doesn't it? Right? I mean, let's just set aside for a second all math formulas. I want these sections I like. Let's be as real as we can. Just somebody just said, hey, forget about all the math formulas. Hey, my town is got 58,000 people now, and it's going up. It's going up by 700 per year. Right? It's going up by 700 per year. How many people, 6 years from now? How many people are there going to be 6 years from now? What would you do? You wouldn't need some fancy math formula. You guys, as long as you had a calculator, you could all figure that out really easily, huh? What would you do? What would you do with the 6? So if the population is 58,000 now, it's going up by 700 every year. 6 years from now, how many people? What would you do? You'd take that 6 and go times the 700. Yeah, you'd go, well, 6 years times 700 per year, and then what? To find out the total. And yeah, you'd add the 58,000, wouldn't you? Because it started at 58. Well, isn't that exactly what we did? 700 times 6, add the 58,000. See how that formula is doing exactly what we know is the right thing to do. That makes sense? So as we move through all these linear formulas on section 4.1 and 4.2, we'll notice that there's two parts. There's a fixed part and a variable part. This part is the variable. In other words, it's what's changing. That's where the 700 went, right? Right there. Because it's changing by 700 per year. And the 58,000 is the fixed part, or the starting part. And this part is the variable. So just know you're going to have a variable part and then a starting part. You're going to have a part that's changing, 700 per year. That goes next to the X. It's by the variable. It's varying. And then the part at the back is where it started. And that won't just be for this one, but for lots of these formulas, it'll work that way. All right, let's try the next one. Feel free to speak up if you want to talk more about it. How about number 2 there? It says, is y equals 73x minus 22 increasing or decreasing? If you graphed that, with the picture, with the graph, it's going to be a line, right? Because anytime you just have x to the first power, the graph is a line, straight line, no curvature to it. Would that be a line going up or going down? So how do we know? What tells us whether it goes up or down? Remember, the negative 22 is where it is not the up and down. That's just the starting point. Remember, the number at the back is just where the things, and that's just what I said up here. Like I said, 58,000, the number at the back, is where the population started. The number next to the x tells you how it changes over time, next to the variable, how it varies, right? So the minus 22 would just mean it would start down here at minus 22, the line would. But as I go forward to the right, is it going to go up or down? This is the slope. It's going to go up 73 every year, isn't it? That line's for sure going up, isn't it? That line is increasing. So what tells you increasing or decreasing? The number in the front. If it's positive, that means it's increasing. We don't care about the number at the back. The number at the back just tells us where we start. The number next to the x tells us if we're going up or down, how we're changing over time. Questions on that? That making sense? All right, so find the slope between those two numbers. Anybody remember the slope formula? y2 minus y1 over x2 minus x1. Yeah, that's the same slope formula. So that's what we use. So remember now, this formula has a built-in subtraction symbol on the top and the bottom. So, you know, that sometimes if you plug in negative numbers, you get a double negative thing. So we've got, this is what? x1, y1. That just means the first point's x and y value. And then this is x2, y2, isn't it? Second point's x and y value. Remember when you have the two numbers, it's always x, y. So the first point, x1, y1. Second point, x2, y2. Okay, so let's do it. Okay, so y2 is negative 14 minus y1, which is 13, over x2, which is what? Negative 10, minus x1, which is 4. We good there? Let's plug them in, and then let's crank it out. So that's going to be, these are both negative. So remember, it's just like money, huh? Negative is a loss, positive is a gain. So if you lose $14 and then lose $13, you lost a lot of dollars. Just add them together there. And same thing on the bottom. If you lose $10 and lose $4, you lost $14. We actually end up adding those numbers, right? A loss and a loss makes a big old loss. And now, two negatives, positive 27/14. Can we reduce that fraction? Does anything go into the top and the bottom there? No. Yeah, no, just no. 2 and 7 go into the bottom. The top number is 3 times 9, nothing in common. So we're done there. Right, let's go to number 4. It's got a graph here. There it is. So number 4 of that line. So how do we do that? Yeah, grab 2 points, yeah. And slope is rise over run. Right? So I'll just grab now, try to get easy points that are right on hash marks, you know, where it's real easy to tell right where they cross. So that'd be right. 0, 0 for sure. We want that one. What's another place where it definitely hits the hash marks? Yeah, I'm thinking about that one too. Right there, it goes right over the hash marks, huh? Right, there's another one the other way, huh? So, and you can use any two of them. It doesn't matter. The left two, the right two, the furthest left and furthest right, it'll all come out the same. I'm just going to use these two. So between these points, if you're going to go from the bottom one to the top one, what's your rise? 1, 2, 3. Remember, you're counting jumps, not lines. I made that mistake back when I first learned this stuff. I remember a teacher, my biology teacher, kindly saying to me, no, Brett, I was counting lines. And she was like, no, you're counting jumps. That makes sense? We're counting jumps, not lines. 3 jumps up. Right, I'm counting gaps, and then 1, 2, 3, 4, 5 jumps right. So the rise is 3, the run is 5, and we're done. And that's all we need on that one. Questions on that one? Number 5. A city's population in the year X equals 1977 was Y equals that big number. In 1953, the population was that other big number. Compute the slope of the population growth or decline, and choose the most accurate statement from the following. Okay. So let me see. So the population, 1 million, whatever, this big number, that was in 77. And then this other million number in 53. So what should we do? Yeah, subtract them, right? Basically subtract the populations and subtract the years and then divide those numbers. Does that make sense? So I don't need to use some fancy math formula. I think you all just sense what to do, huh? So just take whatever it is, 1591. 050 and 1580 250. Subtract those on your calculator. Somebody got an answer there? 10,800? Great, thank you. So it looks like the population went up by 10,800 during those years. And then how many years was that?
24.
Was it? Yeah, so we just take 1977 minus 1953. Oh yeah, you're right on. 24 years. So it went up 10,800 in 24 years. So what are we going to do with the 10,800 and the 24? Because they want us to figure out how many people per year. Like how much did it go up each year if it went up 10,800 over 24 years? Yeah, I put it over 24 years, don't I? Divide by 24. Yeah, just divide that. Somebody got a number?
450.
450, thank you. So 450. So it looks like it went up 450. There's the answer. 450 people. Oh, wait. I did decreasing. That's not right, is it? I didn't notice the decreasing. No, it's not decreasing. It's increasing 450. There we go. Increasing 450 people per year. It went up. Good. We'll try the same thing on the next one. On a bicycle, Maggie rides for 6 hours and is 14 miles from her house. After riding for 12 hours, she's 26 miles away. What's Maggie's rate? What's her speed on the bicycle? So I want to figure out Maggie's miles per hour. Okay, so what do we do here? How do we figure out Maggie's miles per hour? Yeah, she got to be 26 miles away, and back here she was 14 miles away, so you got to subtract that. That means she went 12 miles, right? She went from 14 miles from her house to 26 miles from her house. And then what? Yeah, that was 12 hours minus 6 hours, so she did that in 6 hours. So then we take 12, and what do we do to find the miles per hour? Divide by 6, because it's miles per hour. See how units tell the story? That's how I survived physics. Really, literally. I loved, I didn't, before physics, I didn't really like units. They kind of bugged me. I kind of wish they weren't there. When I took physics, I was so thankful for units. I'd read crazy word problems. I wouldn't have any idea. And then I'd look, it's miles per hour? Oh, I guess I'll take miles and divide by hours. And that often worked if I would just follow the unit trail. So that comes out 2, doesn't it? 2 miles per hour. So she's riding her bike at 2 miles an hour. Is that good? Questions on that one? A phone company charges for service according to the formula C of n is 14 plus 0.02n, where n is the number of minutes talked, and C of n is the monthly charge in dollars. The rate of change of this equation is the initial value of this equation is. So what do they talk about? So let me write it here a little bigger. C of n is 14 plus 0.02n. Okay, so what is that formula? Well, basically you plug in n for your number, stands for number of minutes. So say you talk on your cell phone for like 100 minutes. What's the bill going to be? Well, you would just plug in the 100 there, and you hit the buttons on your calculator. Make sense? So can you tell me, like if I talked for 100 minutes, I would plug in 100 there. If I talked for 200 minutes, I'd plug in a 200 there and hit the buttons on my calculator. So what part is not changing? The 14, huh? That part's just like set in stone, isn't it? That doesn't really depend on, what if I talk for 0 minutes? How about that? What if I say, yeah, I didn't use my cell phone at all this month. I talked for 0 minutes. What's my bill going to be? Yeah, you're still going to be charged $14 because it's 14 plus, even if that other part's 0. So what's the 14? It's the initial charge, isn't it? It's like they're saying, we're going to charge you $14 plus 2 cents a minute. Do you see that? That 0.02 is multiplying by your minutes. That's what that formula is basically saying. See how in linear equations, just like what I was saying before, in a linear equation, you always have one part that's set, fixed, starting amount, and then the other part that's varying, it's next to the variable. It's next to the letter. So this part, so when they say, what's the initial value? What's that answer going to be?
14.
That's the 14, huh? And then when they say, what's the rate of change? What's the one that's changing? That's the 0.02. You don't need that other 0 in the front. You can put it. It's optional. That's the part that's actually changing. That's the 2 cents per minute. The more minutes you talk, the more your bill goes up at a rate of, that's a rate, right? 2 cents per minute. All right, on to number 8 we go. Find the equation of the line through the points. Okay, that's not easy. Let's go get some space to do that one. So let me write it down back here. So it is -2, -6, and 412. And it says, find the equation. Find the equation. Okay, so how do we do this? I think it's been a while since we've done this kind of thing. There's two things. Whenever they say find the equation, and they'll do this a few times in these two sections, 4.1, 4.2. So number 1, you have to find a slope. You got to find a slope. And the slope formula, remember, is y2 minus y1 over x2 minus x1. So there's step number 1. Slope equals y2 minus y1 over x2 minus x1. All right, so this, and so can you do that part first? Might be helpful to write in x1, y1, x2, y2, right? First point's x and y value, second point's x and y value. And so the slope will end up becoming, well, we're going to have a minus in the middle between these guys. And we're going to have y2, which is the 12, minus y1, which is the minus 6. See the double negative there? Subtract minus 6. And then on the bottom, x2 minus x1, like so, huh? Is that good? And then and you know the double negative, that's going to become 12 plus 6 over 4 plus 2, 18 over 6, 3. So 18 over 6 is 3. So the slope is 3. That's step number 1. Step 2, now that you have the slope, use the simple slope formula, the one that has the blanks in the back, has y minus blank and x minus blank. Now there's all kinds of other ways. Probably if you watch the little videos, they'll show you a different way, and that's fine. It doesn't matter to me. I'm good with any way you want to do it. I've found over the years this is actually a little easier for students because it avoids fractions. But if you're really comfortable with fractions, the other way's fine too. So this would be where I probably deviate a little bit from the videos you'll see. But either way's fine. Doesn't matter. So slope equals, and the reason I also like because it's the same formula again. I just found it's easy for students. Same formula, but you can do y equals mx plus b also. So I'm just using the same formula again, except it's just a plain y and x, and there's blanks in the back. And then what do we do with it? Well, then we plug in the slope we just found, right there. That's the slope 3 we found. And what are we going to put behind the y and the x? A y value and an x value, huh? You could use either these two right here, you know, or the other two. It really doesn't matter. It'll work out the same with either two. I'll just grab these two. But careful now, make sure you put the y behind the y. So the y is the -6. I'll put that here. And the x behind the x, the -2. Is that good? See how I just grabbed the y value and put it behind the y, and the x value behind the x. So I'm just using the slope formula a second time, but it's the simple slope formula with the blanks in the back, and I'm only putting in 2 of the numbers, not all 4. And then the slope on the other side. Okay, so then what becomes of that? Well, then this becomes, what is my slope here? This is going to be, my slope is 3 equals y plus 6 over x plus 2, double negative thing again, becomes positive, okay. And now, what do we do when we have this? Remember what we talked about today already? That's just one thing on each side of the, one big fraction on the left side and just one number. That's just 2 things. What do? Diagonal, diagonal, cross multiply, huh? If you just have 2 items, you can cross multiply. What do you do to make that 3 look like a fraction? Over 1. So if you just have one fraction on each side, that's when you're allowed to just go diagonal, diagonal, cross multiply. So let's do it. So the 3 will go there, the 1 will go there. I'll bring it up here. So we have 3 parentheses x plus 2, 1 parenthesis y plus 6. How are we doing? Is that okay? And then you just multiply that stuff out. See what I did there? I just went diagonal with the 3 and the x plus 2, put them on one line, and the 1 and the y plus 6. Multiply 3x plus 6. See, this way we don't have to deal with fractions. That's why I've found it's easier for students over the years. That diagonal thing just gets rid of all the fractions. Now, they want y alone. If you go back to the question, you'll see they have y alone. That's typical. They usually want y alone. So what do? Y is saying, I want to be alone. So what do we do to get y alone? Subtract that 6. Boom. There it is. Oh, and it's just 3x, isn't it? The 6 just vanishes. Y equals 3x. There we go. Y equals 3x. Put in the answer. Y equals 3x. With number 9. Number 9. If f of x is a linear function, f of -3 is -5, and f of 4 is -4, find an equation for f of x. Well, that just looks, this looks strange, doesn't it? But you know, it's exactly the same as the question we just did. They're saying it in different language. Let me help you with the language so you can see that it's exactly the same. 8 and 9 are the same question. How do you know? Well, first off, you have to be able to tell which ones are the x's. How can we tell? There's a lot of numbers up there. How can we tell which numbers? Because we have a -3 and a -5. We have a 4 and a -4. How do you know which 2 of those are the x numbers? How do you know, Daniel?
It's going to be the one closest to f.
Yeah, because, you can just look right here. X is the one right next to f in the parentheses. Exactly. That's always x, huh? And the one that is on the outside is always y, yeah. So this is an x value and a y. This is an x value and a y. Exactly. And so they're basically giving us what? x1, y1, the first x and y value, and then a second x and y value, x2, y2, which is exactly what they did on the last problem, huh? They're just giving us those 4 numbers, x1, y1, x2, y2. So let's do the whole same thing again. Is that what it is? So I'll go back here.
Oh, I did that wrong. Never mind.
So this is number 9. So they say f of -3 is -5. And f of 4 is -4. Okay. And this is x, this is y, this is x, this is y. x1, y1, x2, y2. So step 1 is slope, which is y2 minus y1 over x2 minus x1. So we grab y2, -4, minus y1, -5, over x2, which is 4, minus x1, which is -3. Yeah, so we get the double negative stuff, don't we? So that becomes -4 plus 5 over 4 plus 3, 1/7. Yeah, and then don't divide that. Don't get a decimal. Just leave it just like it is. That's your slope, 1/7. That'll work great. And then so in step 2, remember what you do? You write slope formula again, but this time you just have a plain y and x and blanks in the back, rather than like a y2 or x2 or something like that, just a plain y and x, blanks in the back. And now you plug in your 1/7, your slope of 1/7 over here on the left, and behind the y and the x, you just grab the first x and the first y, or you could grab the second pair, it doesn't matter. It'll work out the same either way. And plug them in behind the x and the y. Be careful to make sure the x goes behind the x and the y goes behind the y. It's easy to accidentally do them backwards. That'll mess you up. Right, so this x, this -3, has to go here behind the x. And the -5 has to go there behind the y. All right, so let's try it. 1/7 is y plus 5 over x plus 3. Is that good? So I'm plugging that slope into the left. So see how we just used the slope formula twice? Once with all 4 numbers plugged in, and then the second time with just the 2 numbers plugged in, and then the actual slope on the left. And then we go diagonal, diagonal. So, and I'm going to bring that over here. That'll be 1 times x plus 3 is 7 times y plus 5. Everybody see what I did there with the diagonal, diagonal? All right, and distribute. So x plus 3 and 7y plus 35. Are we good to there? And what are we always supposed to get alone on these kind? Y. It's all about getting y alone. So what do we? So y's over here saying I want to be alone. So what do we get rid of first? 35. Subtract 35 from both. Boom. And so we get 7y equals, what's that going to be? X minus 32. And then last step, divide through by 7. Remember, when you divide, you got to divide everybody by 7. Does that make sense? All 3 of them, right? Equal treatment. Whatever you do to one side, you have no choice but to do the same thing to the other side. All the terms, every term, equal treatment. No favoritism here. Equal treatment all the way across. So then what do we got? We got x over 7 minus 32 over 7. And that's our answer. That's it. That's it. That's the function they want. X over 7 minus 32 over 7. Is that good? Good question. It's okay that way too. Yeah, either way. Both are right. Both of those are, because it still means both are divided by the 7, huh? Yeah, so both answers are good. Both answers are right. So yeah, on a multiple choice test, grab either one. They're both the right answer. Good. All right. Let's see where we're at. So there was that one. We finished up number 9. Let's go to number 10. More words here. Okay, clothing business. finds there is a linear relationship, there's that word again, linear relationship between the number of shirts N it can sell and the price P it can charge per shirt. In particular, historical data shows that 20,000 shirts can be sold at $39, while 21,000 shirts can be sold if you lower the price a little bit down to $34. I'm not sure I want to pay $34 because it would depend on the shirt. Given an equation in the form, boom, that gives the price P they can charge for N shirts. Okay. That sounds fancy. This is the exact same thing we just did on problem the last two. It's just in fancy words. Let me show you. So basically, I'm going to use X and Y. Now, how do you know what you're going to use? We'll see what they want me to do. Which one of those is where the Y usually sits at the end? So look at that formula. P equals Mn plus B. Where does Y usually sit? Right in the beginning, right? So this guy must be our Y. P is playing the role of Y. He's an actor. He's playing the role of Y. Right? You with me? He's playing the role of Y. For you. So the P is just an actor playing the role of Y, right? It's like the Y. He's just an actor playing the role. Okay, and who's playing the role? Who's sitting where X usually sits? What letter? Can you see that? Do you want me to make this bigger? P equals Mn plus B. What do we normally have? Y equals Mx plus B. So the P is playing the role of Y, and who's playing the role of X? N. See what I'm saying? So just change it back to X and Y. Anytime they talk about P, you just go, well, that's just Y. P's just an actor playing his role. Anytime they talk about N, just go, well, that's just X. And it's the same as the last two questions we've done. Here we go. So when they come in here and they say, 20,000 shirts. Now what are shirts? See up here? Shirts is N. They said it right there. Shirts is N, and N is X. So that's saying X is 20,000. Do you get how I tracked that? Right? They said N is shirts, and I know N is an actor playing the role of X. So 20,000 is X. And then the next number, they say $39. Well, that's price. And what is price? What is P? Y. That's Y is 39. Okay. And then they say, secondly, 21,000 shirts. That's the next X value. You see, that's going to be X2. It can be sold at a price of $34. That's Y2. So X1, Y1, right? X1 is 20,000. Y1 is $39. X2, Y2. That's all that is. We got the four numbers. Here we go again. Same exact thing. See how I can track that? You can track that down? It's just like Y equals MX plus B. We just have actors playing the role of Y and X, P and N. All right, let's do what we did before. So let's take those numbers and crank it out. Okay, so there we go. There's the X and the Y, the X and the Y. So just do the same thing. Step 1, find your slope. Step 2, use the slope formula again. So y2 minus y1 over x2 minus x1. So what do we do when do you guys get to there? Get to that fraction, minus 5 over 1,000. Now, we don't want a decimal. Well, yeah, I don't think we want a decimal. Yeah, and negative. So just make a decimal. Now, if they sometimes they'll say they want fractions. In that case, I would just reduce the fraction, divide top and bottom by 5, right? But if they're good with decimals, I'm good with decimals. So negative 0.005, and you know step 2. We write slope again. This time we put the blanks in the back, don't we? and we plug in the slope we just found, the negative 0.005, and plug in the numbers in the back of y and x. So put the minus 0.005 here, y minus x minus, and then just grab the first x value and put it behind x, and the first y value and put it behind y. And you know what to do from there. Take that decimal on the left and put it over 1, huh? Put it over 1. And go diagonal, diagonal. Cross multiply, like that. Listen, see, so I'm going to get, I'll bring it up to here. So I'm going to get minus 0.005 times x minus 20,000 equals 1 times y minus 39. Is that good? Like that? And then just distribute. And you get minus 0.005x plus, because negative times negative would be positive. And so, is that just 20? Wait, did I do that right? What is it? 100? Thank you. And y minus 39. Is that good to there? And then at the end, y is always saying, I want to be alone. So what do? Add the 39. So y is alone. What is it? Minus 0.005x plus 139. There it is. Okay, so now they want us to put it back in their letters, right? Instead of y equals mx plus b, they said, please write it like this. P equals mn plus b. So same thing, right? Just going to be 0.005 instead of x. Going to be n, and that's it. Everything else is the same, huh? Just put n back in instead of x. They already have the p in the front, so we're good. So it's exactly the same. See how these three questions are all the same? Different ways of saying the same thing. Questions I can answer on that one. Graphs here. Below, one description, one graph, and one equation are equivalent. This is a good little question. Choose the proper set. So they're given. They want us to connect words, graphs, and equations. That's what they're trying to help us make a connection on. Okay, so you start with 3 Xbox 360 games each month. You buy, and each month you buy 3 new ones. You start with 3, and you buy 3 each month. So which, let's jump down to the formulas on the bottom. Which formula on the bottom? Yeah, the second one, the 3 and the 3, huh? So this one's got to go with that one, the y equals 3x plus 3, huh? And that means the other one, you start with 2 and you get 1 new. That's got to go with that one. Right, okay. Okay, now let's try to connect those up with the right graphs. So how do we connect those up with the right graphs? Let's start with the purple one here. So which one is the 3x plus 3 graph? So the one on the left or the right? Yeah, because it starts at 3. Remember, that's where you start, where you hit the y-axis. And then see how it's going up 1, 2, 3 over 1. Up 3 over 1. So it starts at 3, and the slope is also 3 over 1. Whereas the other one starts at 2, right? Starting meaning where does it hit the y-axis? Where does it hit the vertical axis? That's the starting point. Starts at 2, and what's his slope? 1, 2, 3. Wait, I'm a little confused on this. Over. This is going up 3 over 1. This is a slope of 3 over 1. So we don't have an equation that starts at 2 and has a slope. We have one that starts at 2 and goes up 1 per month. Yeah. So I see what they want now. So they want us to basically say this connects with this, connects with this. The other things simply don't connect, do they? The other things don't connect on that. Is that right? That good? You know, we're not going to connect any of the red stuff. You just want to pick, you want something that matches all three. So we have one set of words, it's the top, one graph, it's the left, and one equation that all three go together. It confused me because the red words and the red equation at the bottom do go together, but the red graph does not fit with them. So it almost, I want to kind of grab them. So there we go. Those three go together. All right, let's go on to number 12. Select all of the following tables which could represent a linear function. Now, how can you look at a table and know whether it would be a linear function or not? Yeah, well, you gotta look at what's happening. Remember, because this is x and y. Remember, function values are y values? So it's x, y. Notice what the slope is. Is there a steady slope? How much does this go up by? 25, from 5 to 30, whereas this goes up by 5, right? This goes up by 5, while this goes up by 25. And then this goes up by another 5. Does this, and then this goes up by, I don't know, what's that, 75? Is that one steady slope? No. The right side is supposed to keep going up by the same amount, because that would be the slope, right? That one's not going to, because a straight line, remember, if you have a line function, if you go up and over, it's going to be the same amount. It's going to march off like stairs. So it should be going up by the same, anything that's linear should be going up by the same amount all the way, right? Whereas a roller coaster would not do that, right? Something that had curvature to it would be a different deal. That wouldn't go up by the same slope all the time. So we're looking for numbers that go up the same amount. What about this one? How much is that going up by? Anybody know how much? How far is it from -4 to +6? If here's 0, here's -4. Here's +6. How far from -4 all the way to +6? It's 4 jumps to get back to 0. And then 6 jumps to get out there. How far from -4 to 6? 10. Up 10. Now, how far is it on the next jump? How far from 6 to 16? 10. How far from 16 to 26? There's our baby. That one's going up by the same amount every time. That's the same slope. What is the slope of that one? It's not 10. Remember, what's the other side going up by? 5 every time. So every time the y, remember it's x first and y, every time the y goes up by 10, the x goes up by 5, 2. Remember, slope is difference in y values over difference in x values. How much the y's change divided by how much the x changes. Rise over run, y's over x's. So that y's are going up by 10, while the x's are going up by 5. So the slope of that one's 2. It's a steady slope of 2. At every stage, it's going up by 2. So on this question, first off, they're going to give us a function, and they're going to say, what's the rate of change of the function? Do you know which of those numbers is the rate of change for this function? Yeah, it's the 10. It's the slope. Rate of change is the slope. Y equals mx plus b. And what's the initial value? That's the -2. Yeah. So the first number is the slope. The number next to x is the slope. and the other number is the initial or starting value. I called it starting value, initial value, same thing. All right. Now, their last question over here, it's saying, is this graph horizontal, vertical? I already forgot. What was it? Oh, increasing or decreasing. Horizontal, vertical, increasing or decreasing. Those are the options on the behavior bar over there. So what do you think? Is a graph with a slope of positive 10. Increasing, decreasing, it's going up, isn't it? Positive slope's going up. It would be a graph that would look like this. It would be going up. So it's increasing. As you go to the right, it goes up. How about the next one? What's the rate of change? So for this function now, what's the rate? Yeah, again, the rate is what's next to the slope. I'm sorry, it is the slope. It's what's next to the letter. So they switch the order to try to trick us. But what's next to the letter? -9. The -9. So this one's the slope now because they put the letter on the right side, didn't they? And what's the initial value?
9.
The +9, the regular 9. You can just make regular 9. That makes sense? So the slope is what's next to the letter. It's next to the variable. It's what's going to make it vary, make it change, right? All right, and then is that one increasing? If you were to graph it, what would the graph look like? Would it go up or down? Yeah, the rate of change tells you it would go down. So it's decreasing, isn't it? All right, let's try the third one. 4a. Now notice he's missing one of the numbers. He's only got the number next to the letter, the variable. He doesn't have the other. So what's the other number really? 0. Yeah, so okay, here we go. What's the rate of change? That's the 4. What's the initial value?
0.
That's the 0. Now, is that one going up or down? Increasing, because again, when it's all about the rate of change. If it's positive, that's increasing. If the slope is positive, the graph's going up. If the slope is negative, the graph's going down. That's the rate of change, the slope. Last one. Now the last one, he's only got a number. He's missing the variable part, isn't he? So let me help us by putting in a plus 0x. I mean, that doesn't change anything, right? I just added 0. That does nothing, right? 0 times x is just 0. And adding 0 does nothing. That's still just a fancy way to say -5, isn't it? I made it look different without being different. Right? We do that a lot in math. I call that plastic surgery. Remove the wrinkles so it looks different and makes it easier for us to answer the questions. Question, Lejeune.
Wouldn't RA equal 4A be vertical?
It would not. I'll come back to it. Let me finish this one, and we'll get back. Well, yeah. Well, let me just say for now. Well, yeah. Let's do this one in a minute. It'll make more sense. So, so what's the slope on this one? What's the slope? 0, because the slope is what's next to the variable, huh? It's what makes it vary. What's the initial value? -5. Now, what would this one look like? So remember, function values are what? X or Y? Y. That's basically saying y equals -5. That 0x thing I threw in there is just 0. It's not really there. So that's really saying y equals -5. I don't care that they wrote C, parentheses W, whatever. That's a function, and functions are just y. They're just an actor playing the role of y. That's all functions are. An actor, it's Mel Gibson with the statue. He didn't really lead Scotland in a rebellion. He just was the actor, right? He wasn't the hero. He's just he's a very good actor, I think, but not the hero of the real historic story. Same way, y is the real deal. That function in the front is just y, okay? So what? Well, that means that equation says y equals -5, huh? So that means, which one's the y-axis? This is the x, and this is the y, huh? Right? So that means I need to go where y is -5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, and put a horizontal line. It's horizontal. Well, how do I know? Because it hits the y-axis where? At -5. That's saying y is -5. Boom. Right on the y-axis at -5. That's a horizontal line. So that one's horizontal. That's why that other one's not horizontal. So you're only going to get horizontal if you have a slope of 0. That makes sense? His steepness, his slope, is 0. He has no steepness. So if that's a roof, that's a flat roof. It's not steep.
So then the RA would be vertical.
So vertical is something entirely different. None of these are vertical. We'll see it maybe in another problem. But if the slope is 0, that's going to be a horizontal line. If the slope is positive, that's going to be increasing. Negative is going to be decreasing. This one's positive, so it's increasing. Positive slope increasing, negative slope decreasing, 0 slope, flat line, horizontal. All right, let's pick it up on number 14. Write the equation of a line parallel to the line that goes through the points. Okay, so yeah, these ones are not easy either. So let's try this. So I'm going to move it to a fresh screen here. There. Okay, so I'm going to move it over. So this is number 14. So parallel to y equals -x minus 2. Going through the point -4, -3. Okay, so now remember the two, and what are they saying? They're saying, find the equation. It's another one, just like these last few, of find the equation. Okay, so they want the equation. So what do we do? What's the first step? It's just like all the others have been doing. What's the first step? Find the slope, right? And then once you have the slope, write the slope formula. Okay, so now this time though, the slope's actually going to be easier to get than it was on the last one. Why so? Where's the slope? So look at this. They're telling us that our equation is parallel to this equation. This other equation. Ours is parallel to that one. So that other equation, what's the other one's slope? Can you tell? Yeah, because remember it's y equals mx plus b. So right here there's a -1 in front of x. Remember whatever's in front of x is the slope, isn't it? Remember y equals mx plus b? So that one's slope is -1, and our line is parallel to that one. So we're the same steepness, right? However steep that one is, ours is the same, parallel. So that means our slope is -1, just like that one's slope, automatically. Does everybody see that? That one's slope is -1 because slope is always in front of x. And then ours is parallel to that one, so our slope's the same. So our slope is -1. Well, boom, that just made step 1 easier. What do you do for step 2? You know what to do. Right, slope equals y minus blank over x minus blank. What do we do now? Plug the slope into the left side, right? The slope we just discovered. And what do we put in the right side? Yeah, this is our x1, y1, right? So put the y behind the y and the x behind the x, and away we go. So this is going to become -1 equals y minus -3 over x minus -4. Good to there. See how it's just the same thing as usual? They're just handing us the slope by giving us that other equation. We just find the other equation slope -1, and that's our slope too. And now you know what to do here, right? Cross multiply. So I'm going to kind of zip it along here in the interest of time. That's going to become x plus 4, right? The double negative becomes add, you know about all that. And this will be 1 times y plus 3. Bring it up here, distribute, minus x minus 4, distribute, y plus 3. Last step to get y alone. Subtract 3. Y equals minus x minus 7. 15. So, find the equation parallel to, it's the same. I'm going to actually skip it. Do you see it's the same? Let me just do the initial setup, then I'll go dot, dot, dot. Right? Find the equation. So you need, with step 1, find the slope. What's the slope?
6.
Yeah. Y equals mx plus b. The m is right there. It's 6. The slope is 6. Step 2, write the slope formula. Y minus blank, x minus blank. I'm going to go dot, dot, dot. Exactly the same. How about number 16? Let's jump down to 16. Find an equation for the line that passes through the point. Sounds like the same thing again. And then it says, and is parallel to. And they give me an equation. Parallel to. So you know step 1, get the slope. Get the slope. We good? Am I rushing you along too fast? Is that good? So on number 16, we got to find the slope. Now, here's the trick. Do you see the difference in this equation? This time, y is not alone. See how in the last one, y was alone, y equals 6x plus 8, and the one before that, y was alone, y equals negative x minus 2. See, when y is alone, y equals mx plus b, then the m will be, the slope will be whatever's right next to x, huh? Is that good? But what about when the y's not alone? Well, you better get y alone, is the answer to that. So, first, get y. In order to find the slope, first get y alone. So take the equation, minus 5x plus 6y is 4. And I'm going to take, well, here I think I better move it down. Oops. Move it down here. So minus 5x plus 6y equals 4. So here's the dividing wall. And y is saying, I want to be alone. So what do we do first to get y alone? Add the 5x. Right? We're over here on the left side. And y is saying, I want to be alone, which means get rid of this negative 5x, please, and get rid of this 6 so that I can be alone on my side of the wall. Does that make sense? So to get y alone, we add the 5x to both sides. And that cancels, and we get 6y is 5x plus 4. Good so far? And what's the last step to get y alone? Divide through by 6. And we got to go all the way across. Okay, now I don't really care about simplifying that 4 over 6. The only reason I'm doing any of this right now is because I want the what? The slope. I just want his slope. He's not my real equation. He's some other equation by which I'll get my hands on a slope. So what's the slope then for that? Now that y is alone, it's y equals mx plus b. So what's the slope? 5/6. So the slope is 5/6. So that's step 1. Am I losing you? So all of that is step 1. That's how we get the slope. That's how we find the slope. So now we've got the slope, and then we say, okay, now for step 2, what do? You write slope equals y minus blank over x minus blank. What is the slope we found? 5/6. So then you just grab that and plug it in over here. 5 over 6 is y minus over x minus. And what do you put in the back of the x and the y? Yeah, that point. Here's the x1, here's the y1. Put the x in the back of x, negative 4, and the y in the back of y. And cross multiply and take it from there. I'm going to go dot, dot, dot. It's the same from there. We've done, I think, 4 of them. Is that good? So the only difference on this one was finding the slope, the initial work of finding the slope.
Once you cross multiply.
Over here, y minus 4, x minus, that's where we were, right?
Yeah.
Right to there, and just go diagonal, diagonal, like usual. So this is step 2, right? Slope equals y minus blank over x minus blank. So we'll get 5. That'll be x plus 4, because double negative becomes positive, is 6 times y minus 4. Diagonal, diagonal. Just like that. And then distribute. 5x plus 20. 6y minus 24. And
24 to both sides.
we're always wanting to get y alone. So add the, yeah, so y said I want to be alone. Add the 24 to both sides. So that'll be what, 44? Last step to get y alone. And when we divide, what do? All 3. So that'll become 5, 6x. Oh, yeah, so do you mean that fraction there? Yeah, so anytime we have fractions that need to be reduced, we do that. So that's just always the case. So that would be, yeah, divide by 2. Top and bottom there, so that'd be what, 22 thirds? Yeah, good. That's exactly right. Exactly right. Just reduce that to 22 thirds. And there we go. Y is alone. All right, so this one, sketch the graph. Do you remember a little bit about graphing linear functions? Remember that you start on the middle y-axis with that number. So whatever number's off to the right, you start on the middle y-axis with that number. So that would be right there. Up 3 like that. If that was a subtract 3, I would start down here at minus 3. Okay, now you march off the slope. So all we need is 2 dots. If we can just get 2 dots, then we connect the 2 dots and we have the straight line. So the first dot is at up 3. The second dot, remember slope here is rise over run. So that means you go up 2 over 1, 2, 3. Up 2 over 3. Connect the dots. There it is. There's our line. So the number that's off to the right, that's your starting dot, up 3. And then you do rise over run. The question is that graph a linear function? It almost seems like a trick question. Like, is it a line? Yes. That'd be nice to have a lot of those on the test, huh? There's really nothing more to it. They're just simply making sure you know that they all look like lines. That's why they're called linear. Number 19. Find the intercepts. Is that about it? And then 20. So we're almost there. So 19. All right, so it's saying find the X-intercept, find the Y-intercept. Okay, so how do we find intercepts? So it's been a while. You can tell this is X and this is Y, right? And this is X here and this is Y. So for the first one, for this X-intercept, notice that the Y value is already 0, isn't it? So that means I'm going to take this equation, 4x plus 2y is 8, and I'm going to plug in for y right there, 0. Everybody see what's happening? I'm just taking that 4x plus 2y equals 8 equation. And for the first X-intercept, they're making the y value 0. So I just go, okay, I'll make the y value 0. Just pop in a 0. And so that just becomes 4x is 8, because this part's just gone, right? 2 times 0 is just 0. That's just gone. So 4x equals 8. How do we finish solving for x? Divide by 4. So x is 2. Boom. Now we redo the same thing again. Come down here. This time we're going to start with the equation 4x plus 2y equals 8 yet again. But this second time for the y-intercept, they're telling us to put in x0, aren't they? So I'm going to plug in 0 for x. So that's gone. 4 times 0 is 0. And how do we finish solving for y? So I plugged in 0 for x. So what do I do to solve for y there? Divide by 2. Y is 4. Everybody see what we're doing there? So I just plugged in 0 for y the first time and 0 for x the second time. Now they want me to put those two dots on the graph. So let's put the dot on the graph, the 2, 0 dot on the graph. Can you do that? So it's right here, isn't it? From the middle, it's over 2, up 0. Now can you put the second dot over 0, up 4? 1, 2, 3, 4. Right there. Over 0, up 4. And then the last thing is they want us to connect those two dots with a straight line. That line is the graph of that function. So when you find two dots and connect the two dots with a line, you've graphed the function. That's another way of graphing the function, different than the way we did it a second ago on the previous problem. Question. Y equals minus x minus 2. They want me to take that equation and they want me to plug in different x values. So they're starting with x is negative 2. So I'm going to go, okay. Now watch out here. There's the negative that's part of the formula. And then I'm plugging in negative 2, like so. Does that make sense? I just took that negative 2 and plugged it right in there for x. Yeah, and then the two negatives is going to make it positive 2, isn't it? That's going to become positive 2 minus 2, which is 0. Is that good there? And then we just keep on going. So I'm gonna go dot, dot, dot.